Right, how far must a 2000 kilo pile driver fall if it is to do 3.92 by 10 to the power of 5 joules of work? Right, so here's our pile driver, and it is like a big hammer, and it's falling downwards, right? So it's falling, so it's G, it's acceleration due to gravity anyway, 9.81 meters per second squared is what's causing it to fall. Or that's the rate of fall, the rate of acceleration. Now what's work? Work, I have it written down here. Work is a measure of energy transfer, right? That's one definition of work, right? So as the pile driver falls, its potential energy is converted into kinetic energy as it falls. So it loses potential energy because it's losing height, but it's gaining kinetic energy because it's accelerating and its velocity is increasing. So we're going to be using these formulas here: PE, potential energy, and kinetic energy. And for the falling one here, potential energy, see the height, how far must it fall until it's lost this much potential energy? In other words, until it's transferred this much potential energy, that much joules from potential energy to kinetic energy. So where PE there, potential energy equals mgh, we can sub in 3.92 by 10 to the 5, because that's the amount of potential energy will be transferred into kinetic energy to do this amount of work. So that's going to be the mass, 2000 is the mass, multiplied by G, which is 9.81, multiplied by the height, which we don't know. So we can multiply 2000 there, 2000 by 9.81 times h, right? So what's 2000 multiplied by almost 10? 9.81, 19,000. So we get 19,620 times h equals this figure here, 3.92. So we'll just make a wee bit of space there, show things up a bit. Right, now, so to get h, we divide both sides by 19620. So we get 3.92 by 10 to the 5 on top. Use the fraction key on your calculator, 19620. Divide them two numbers and that'll give you h. So our height is, fraction key, 3.92 by 10 to the 5 divided by 19620, and press SD there, and I have a height, I come out there with a height of 19.98. I'm rounding that to 2 decimal places, and that's going to be in meters. So that's our height. Oh, what happened there? 1 second now. Yeah, okay again. Oops. Now, that's our height. So what the next part of the question was, that was part 1 answered, right? That's the answer to part 1. The next part was, assuming that all potential energy of the pile is converted into kinetic energy without any other losses, calculate the velocity of the pile driver as it strikes the pile. Now I'm just going to pause this here for a second. Right, we've just done section 1 and now we're going to do section 2 there. Assuming that all the, yeah, I just read that maybe a minute ago. Anyway, I'll read it again. Assuming that all the potential energy of the pile is converted into kinetic energy without any other energy losses, calculate the velocity of the pile driver as it strikes the pile. Well, now it's gone 19.98 meters before it bangs into this object, right? Bang. It's after traveling 19.98 meters down. So we have that from part 1. And the potential energy that was transferred was 3.92 by 10 to the power of 5 joules. And that was transferred into kinetic energy. So our kinetic energy at the point of impact is going to be 3.92 by 10 to the 5 joules. We're asked what was the velocity. So here, number 9, this formula here relates kinetic energy, velocity and mass. We also know the mass. The mass hasn't changed as 2,000 kilos. So we just get this formula here and we sub in our values. 3.92 by 10 to the 5 equals a half times the mass. So we use brackets here if we like. 2,000 times our velocity squared. So a half times 1,000 or 2,000 will give us 1,000. So we'll have 1,000 multiplied by v squared equals 3.92 on the left. And now we can divide both sides by 1,000 and we end up with 3.92 by 10 to the 5 divided by 1,000 equals v squared. So run out of room here again. Let's move things up a little bit further maybe. Now to dig out v then, we're just going to get the square root of both sides. So we'll end up the square root of this structure. V equals the square root of 3.92 up by 10 to the power of 5 all over 1,000. So carefully put that into the calculator. First of all, select the square root key, then the fraction key. On top then we have 3.92 by 10 to the 5. Downstairs we have 1,000 and press equals. And SD there, well, we get 14 root 2, right? So I mean, if you wanted to be fancy, you could say the velocity was 14 root 2 meters per second. And putting that in decimal, press the SD key, and I get 19 point, rounded to 2 decimal places, 19.80 meters per second. So there we go, job done. Just pause that now. Thank you. Now we could do that another way perhaps. Up top what I did there is okay, but we could, it's perfect, we could do v squared equals u squared plus 2as. That's a kind of a classic formula. U squared, the initial velocity of the pile was 0 because it was dropped, right? So you scrap that and you'd have v squared equals 2as. V, get the square root of both sides. V equals the square root of 2 times a times s, right? And the pot was that'll be 2 by 9.81 because that's acceleration due to gravity, times the height that we got earlier in the question there. That was 19.98, right? So 19.98 goes in there. Bang all this stuff here into the calculator and you will also come out with 19.80 meters per second. Now it will be helpful if you kind of understand how to do it both ways, but I'd say both ways will get you the marks there.